let's see if the recording starts. All right, recording has started. You guys are the lucky recorded session today. Let me go ahead and share my screen. There. Okay, so chapter 13. This is arguably one of the harder chapters you'll do. So the beauty about this examination is that chapter 12, I think, is very easy and straightforward. It's market history. It's an open book test, so you have your slides. If you forget anything, you can just look it up. Chapter 13 is a bit harder, and it requires a lot of quantitative thought, and for you to, reason quantitatively about some portfolios that you'll be looking at, and you want to calculate their returns in different states of the economy. Okay, so the idea is we're going to look at how to calculate expected returns, right? We'll also, again, we won't forget about variance and standard deviations because, again, that's sort of the innovation of finance in some sense to economics. Like way back in the day, how did they split off from economics? I mean, I would say finance is still a subset of economics in overall, but one of the things that they started to consider, which was important, was individuals' aversion to risk. And if you're going to measure aversion to risk, you have to measure risk, and that's how you use the standard deviations for. So we'll do that, some of that here, and we're going to see how we can calculate standard deviation of portfolio returns for various portfolios, and then we'll look at the security market line, which again is a fun part of the chapter, but it requires you to be analytically tuned in. So again, sorry, but fair warning, it's going to be kind of a hard chapter. But I think if we go slowly, and if you ask me questions when you encounter information you don't quite understand, I'm happy to slow down and kind of go over it for you. Also, be very mindful of these notes, okay? So we'll even be looking at some of the notes in addition to the slides during this lecture. But just recall, when you're going through the slides and you forget how to do something, frequently the notes have a detailed breakdown of how to actually do that thing. So utilize them, and that should help you a little bit. Okay, so let's talk about expected returns. Expected just means sort of average, right? When you take the expectation of something, you're basically taking its average. All right. So the idea is expectation is a term that comes to us from statistics and probabilities. And so if you take the expectation of everything, what you're really doing is you're taking the probability of that thing happening times its return. Okay. And you're adding all of them together. All right. So that's exactly what you see expressed here in mathematical terms, that an expected return is just you look at all of your portfolio. Okay. You figure out the portfolio weight, which is going to be our little p, your PI, and then the return on I. I just stands for all of your assets. So how do you kind of interpret this summation? Well, what you would look at is you would look at the sum by, let's say you had three assets, okay? So, or you had three expected states, excuse me. So you had the probability of state one and the return in state one, right? So the I becomes 1, P of 1 times R1, okay? You had a second state, 2, right? P becomes 2 and R becomes R2, right? And so you have those probabilities. And then you have probability 3, so P3 times R3, and so on until you reach N, which is the total number of states that you have, okay? Now, this is a lot easier to do it with numbers. So when you think about numbers, we're gonna think about them with practical examples. So first, we've got a state where the economy is booming, the state where the economy is sort of behaving normally, and some probability of recession, okay? And these are the probabilities, all right? Now, again, what do the probabilities usually add up to? They should add up to 1, right? So here we have 3 question marks for recession. What's the probability of recession if you look at those 3 possibilities? 0.2, that's exactly right. And how did you get it? Exactly. So we have 0.3, we have 0.5, but all of them added together have to equal 1. So 0.3 plus 0.5 plus what gives you 1. One equation, one unknown, you solve for that x. And so you can see that this recession blank can be filled in with 0.2. Okay, now you have the predicted returns of the stocks. So you have the stock C, right, and the stock T. I mean, you can add your own ticker symbols here if you want to. Stock C can be Apple and stock T can be Tesla, just whatever it is, right? And you can see that intuitively, although this isn't always true, they return more in a boom cycle than they do in a recession. Okay, so in a state where the economy is booming, right, you have a return of 15% for stock C and a return of 25% for stock T. In the normal state, you've got a return of 10% for stock C and a 20% for stock T. Okay, and in a recession, they barely return anything at all. So stock C returns 2% and stock T returns 1%. So let's just take a brief look at our formula. This is going to be our formula, right? So we're going to take the P's, those are going to be the probability of being in a boom cycle, in a normal cycle, or a bust cycle. And then our corresponding R's are going to be the return for these securities in that cycle. Okay, so let's look at how we do it for the return on stock C and the return on stock T. So probability of boom is 0.3. So 0.3 goes right here. Okay. For stock C, the return is 15%. So 15 goes here. For stock T, the return is 25%. So 25 goes there. Okay. Now, the same thing for the normal state of the economy. It's about 50% chance we have a normal state. Okay, so that's the 0.5. And then you plug in the percent chance. That's the 10% chance. Okay. Or the 10% return, sorry, the percent return. Okay, so here again, 0.5 or 50% chance of recession times the 20% of return that stock T has in the event, or not recession, sorry, of a normal state. And so you plug in the 20% that stock T returns in the normal state. Okay, and finally, again, we use our calculation for what the probability of recession was, which is about 20%. We enter the 0.2, okay, and then we enter the percent returns. So here for stock C, the percent return in a recession is 2%, hence 2. And then here for stock T, the percent return in a recession is 1%, hence 1. All right, now we just add all of these together. And so we see that the expected return for stock C is 9.9%, and for stock T, it's 17.7%. Okay, now let's say you forgot how to calculate the probability of recession. You would go to the notes and you would find it. Okay, and let's say, for example, you forgot to calculate the risk premium. Okay, let's say your risk-free rate was 4.15%. Okay, well, again, you can go to the notes, and even though the slide doesn't ask for this, the notes show you how you would calculate the risk premium. Okay, and again, all you would do is just subtract the return rate on the risk-free asset from the return on these stocks, and that's the premium that these stocks give you for investing in them and taking that risk. Okay, now we're going to look at the variance and standard deviation. Okay, so remember, this is another formula for variance. Okay, so here the big difference is that is not so much the R minus the expectation of R. We already know R minus the expectation of R from our formula in chapter 12, because that's just taking a particular return and subtracting the mean from it to get the deviation from the mean, and then we square it. We divide it by 1 over n minus 1. But you don't see 1 over n minus 1 in this problem. The reason for that is that it is replaced by pi, okay? And pi is just the probability of that particular state, just kind of like we just talked about with the, boom, normal, and recession cycle. Okay, so remember pi, all of the pi's have to add up to 1. And the reason you don't need a denominator, you don't need 1 over n minus 1 is because pi is a ratio, right? It's a real number. I guess it doesn't have to be a rational number. It's not necessarily a ratio, but it is a real number. And so the real number that is a decimal point that is less than 1 generally can be, or most cases can be expressed in sort of a fractional form. I guess not if it's pi. Don't worry yourselves with that distinction. But the idea is that because that P sort of represents a ratio, right? This is 30% of your portfolio, which is the same thing as saying 30 over 100, right? Because it represents that, you no longer need to divide by n minus 1. It takes the place of that divisor. So, you know, in case you sort of forget that, all right, you can again review it in the notes. Okay. So because you're using probabilities, you don't actually need this division by n minus 1. But the rest of it is pretty straightforward, right? It's still the same because all you would do is you would take the sum of these squared deviations from the mean scaled by the probability that that state occurs. Okay. And that will give you not standard deviation, that will give you variance, because variance is standard deviation squared. So if then you wanted to get the standard deviation, you just take the square root. Okay. Does everybody understand that? Yes, sir. Yes.
How do we?
It's the probability of the state. Does that make sense? So remember in chapter 12, right? We had, like, let's say average returns, right? And if you think about it, the average returns just came from year 1, year 2, year 3, year 4, and we added them all together, right? So there are these various, if you think of year 1, year 2, year 3 as states, right? There were a bunch of different states. That's why you were dividing by 1 over n in the population, or 1 over n minus 1 in the same. But here you have a different way to think about states. Rather than thinking about them as different years, okay, if you think about them like, you know, a 30% chance of a boom economy, 50% chance of a normal economy, 20% chance of a bust economy or a recessionary economy. So because you think of them that way, right, all of a sudden you don't have a whole bunch of different years. You just have different probabilities that certain things will happen, let's say next year in 2025. So when you have these probabilities, you no longer need to divide by the number of quote unquote years, because there are no years. This is the expectation for the future, 1 year. But it's a probability. So this kind of eliminates the need to divide by n minus 1. It replaces it because if you remember how we did standard deviations in chapter 12, in chapter 12, we didn't have a probability. So you had to scale it back down for the fact that you're using many observations. Here, what scales it back down is, you know, the fact that you've got this this probability. All right, that kind of makes sense, hopefully. Okay, because the way we could do it, I mean, let's go back here. You know what we could do? Instead of giving you a probability of 0.3, we could give you a sample. And the sample will have 10 years. And 3 of those years will have this return for C and this return for T. 5 of those years will have this return for C and this return for T. And 20%, right, or 2 out of 10 of those years would have this return for C and this return for T. And once you have that, you can use the chapter 12 method and divide by n minus 1, and it should give you the same result, or in that case, dividing by n, because it would give you the population, it should give you the same result as this. Does that kind of make sense? Okay, so that's sort of the way that we account for it is instead of giving you 10 different returns and, you know, assigning 3 to boom, 5 to recession, 2 to or 5 for normal, 2 to recession, we're just going to give them probabilities and treat them all as approximations of the return for the next year. Okay, and so if we do that, we also want to approximate the standard deviation and variance, and so that's how we would do it in this context. All right. So a theoretical example requires a good numerical example, so we'll do it numerically. Let's look at stock C. Okay, so we know that the average return, which again, we got the average returns up here. That's where those numbers are coming from. So remember that stock C in the first year, in the first state, had a return of 15%. The first state being the boom. We subtract from that the average return across all states, and then we square it, and then we multiply it by the chance that that happens, right? And we get all of that from the prior chart and the average calculation. So the chance that it happens is 30%. This is the average. This is the return in that particular state. This is the average return across all states, and then we square it. Okay, we do the same thing for the normal state. Okay, the normal state, there's a 50% chance that it happens, so we multiply by 0.5. Then we take this 10% return and we subtract the average return across all states, and then we square it. And then we do the same thing for recession. So now that we've done those three things, okay, we can go over here and see that the variance is 0.002029. All right. But it's much easier for us, instead of looking at variance, which gives us the percent squared, whatever that means. Okay, we can take the square root. And when you take the square root, you get 4.5%. Okay, so that's the square root. So that's going to be the standard deviation for you. All right. Now we can do the same thing for stock T. Okay, and the application is exactly the same. All right. Notice you have 0.3, 0.3, 0.5, 0.5, 0.2, 0.2. Okay. All you're doing is plugging in the different returns in those states, right? And you're subtracting a different average return because, again, the average or the expected return for that stock was different than for. After you enter all of those into the formula, you still get variance 0.007441. And then if you take the square root of that variance, well, you get 8.63. Okay, and the square root of variance is your standard deviation. And now, if you recall that bell-shaped curve that I talked to you about, right? Now you can draw those bell-shaped normal distribution curves for your stock. Okay. Now, here's another example, all right? This is the workout for this example, but we could just kind of go through it here kind of slowly. All right. So we've got a situation where you have 4 states. There's a small typo in the slide, like it should be here. Fix that in your slides. So basically what you've got here are probabilities of 4 different states. It doesn't have to be 3 or 4, it can be 100 different states, but they all need to have an assigned probability. Okay, and then you have the ABC Inc., which is our company. You have the return in all of those states, right? So now let me kind of, well, you guys can see this at the bottom, hopefully. Okay, this is the workout for this, and we do it exactly the same way. So just because it's a different problem, don't panic, right? It'll be just fine. So here you just assign the probability 0.25 times the return in that state. And there's a 25% chance of a move. There's your 0.25, and then the security returns 15. There's your 0.15. Okay, then there's a 50% chance that the economy is in the normal state. There's your 0.5. And in normal state, it returns 8%. There's your 0.08. Okay, and so on, right? For each state, you multiply the chance that that state happens times the expected return in that situation. Okay, and that gives you the overall expected return, which is 8.05%. Now, with that expected return in hand, because again, you got to get the average, you got to get the expectation before you can get the standard deviation. Now you can calculate the standard deviation. And so again, all of the weights, all of the probability weights remain the same. Okay, 0.25, 0.5, 0.15, and 0.1. And then the only thing you do here is you add in the squaring of the deviation from the mean. So you have the actual return, like here it's -3%. You subtract from it the average return, right? So minus 0.0805, and then you square it. And when you squared all that, right, you get the variance, and you add it all together, you get the variance. And then you get the standard deviation by taking a square root of that variance, okay? So now, again, why do we do this? Because you now can form that bell curve. Everybody wants to see that bell curve. There it is. You can form that bell curve using this, okay? So now let's talk about another way of weighting by talking about portfolios, okay? So before we were weighting based on probabilities, but you can also weight based on how much stock, how much Tesla stock you have, how and then later on in this chapter, to really blow your mind, right, we're going to combine those weightings, right? And so we're going to weight on probabilities, and we're also going to weight on your portfolios, okay? So let's kind of take a look at portfolio weights. This should be kind of, if any of you guys trade or even engage in paper trading where you don't trade real money, but you play around on the stock market to see how you would do. So here you've got these portfolio weights. And what you do is, let's say you had $15,000 to invest, and then this is what you chose, okay? And if you chose this, right, this was your portfolio, and these are all stock tickers, you can quickly figure out what portfolio is dedicated to what. How do you do it? Well, you just go over here and take what you invested in C and divide it by 15,000, okay? Since you invested 2,000, you have 15,000, you can cross out the zeros, right? So it's just 2 divided by 15. Okay, KO is 3 divided by 15. INTC is 4 divided by 15. And the rest is BP, which is 6 divided by 15. Now, just like in the other, in guessing the portfolio weight, or not guessing, but solving for the portfolio weight, let's say I gave you the investments for C, KO, and INTC, but I didn't give you the investment for BP. And I told you, the entire amount of the portfolio was invested. How would you find out that BP was 6,000? Right? If you didn't know. Huh? Well, yeah, I mean, in your portfolio, if I told you spent $15,000 on 4 stocks, the first stock 2,000, the second stock 3,000, the third stock 4,000, how much did you spend on the fourth stock? Whatever's left, right? Y'all are laughing, but nobody's giving me an answer, so I'm still waiting. But the idea is you just take 15 and you subtract those numbers from it. So 15 minus 2,000 minus 3,000 minus 4,000 leaves you $6,000. So when you see a question on the test and it gives you almost all the portfolio weights except one, well, that's how you figure it out, right? So don't guess, oh, he didn't give me, Professor, you didn't give me all the portfolio weights. Well, you need almost all of them, but not all of them. You can infer the other one. All right, so now, once again, here's a different way to weight this equation. All right, so now you've got a situation where you've got investments 1 through M. Okay, that's where J equals 1 through J equals M. Okay, and we're going to take their expected returns, right? And we're going to weight those respective returns by the weight of that stock in your portfolio. Okay, when you sum all of those weights times returns, right, you get the expected return for the entire portfolio. All right. So let's take a look at what that would look like. So let's say you use the portfolio weights from the prior problem. Now, in the prior problem, right, here's what they gave us. Okay. And then they give us these returns, the expected returns. So again, the weight of the portfolio of C, right, is 13.3%. So we use that weight. And then we multiply that times its expected return, right? Then we use the weight of K0, which is 20%, and then we multiply it times its expected return. And we go down the line and do this for every stock in our portfolio, and then we sum it up. We add all of them together, and we get 15.41. All right? So that would be the answer. Like, what is the expected portfolio return for that portfolio? Now, we also want to calculate portfolio variance and portfolio standard deviation for the same reason as before. Okay, so we compute the portfolio return first, then we compute the expected portfolio return using the same formula as for an individual asset, and then we compute the formula variance using the same formula as for an individual asset. Okay, so again, similarities between individual assets and these. So let's look at this portfolio. Let's see, is this where my notes help me? Yeah. Okay, look at all that. You want me to write that on the board? I can if you want me to. All right, so but let's just look through it intuitively first. Okay, so you've got two states. This problem kind of narrows it down. Okay, you have stock A gives you 30% in a boom and negative 10% in a bust, and stock B is a hedge, right? So its returns in a boom are actually negative, but its returns in a bust are actually positive. Now, by the way, this is kind of important because you see that this is a common technique, right? I'm not sure if the economy is going to be in a bust and a boom, so I split my investment between an investment that is correlated with the economy. When the economy goes up, this asset goes up, and an asset that's negatively correlated with the economy, which means if the economy goes up, this asset goes down. So that if I'm wrong and the economy goes down, I still have an asset that is giving me a positive return. Okay? So we invest 50% of your money in asset A. Okay? What are the expected return and standard deviation of each asset? And then what's the expected return and standard deviation for the portfolio? All right, let's go step by step here. Okay, so if A and B are the only choices, what percent are you investing in asset B? Well, I invested 50% of it in A, so I invested the rest in B. That's 50% in B. Okay, now let's look at the expected return for asset A, right? Probability of a boom is 40% or 0.4. So we multiply 0.4 times 30 because that's the result for A or for asset A in that state. Now, plus 0.6, right, is a bust. And in plus 0.6 being a bust, you get this negative 10 return, which we get from again, our chart. So what's the expected return? Well, when you add those two products together, you get 6%. And then again, we can calculate the variance, right? All you do is you take the same probability of this state, 0.4, and then you get 30, which is your return in that state, minus the average return squared. Okay? You add all of that together, you get 384% squared. What's a percent squared? Who knows? Let's take a square root of that. And so now the percent is back to being a percent, and it gives you a standard deviation of 19.6, right? Okay, so that's good. And then we'll do the same thing for asset B. Okay, 0.4 times negative 5 this time, because remember, it's the hedge asset, plus 0.6 times 25. That gives you an expected return of 13. Standard deviation of 14.7 calculated the same way, right? We went over here, we took the return in that state, subtracted the average return, squared the whole thing, and then multiplied it by the probability of that state. Standard deviation of 14.7. Okay, now let's come down here for a minute and let's look at how we're going to solve for the portfolio. Okay, so for the entire portfolio, okay, we have 50% in asset A and 15% in asset B. Okay, so then when we do that, right, you see in a boom state, the return is 12.5. which is what you see here. Okay. And then in a bus state, the return is 7.5, which is what you see here. So what is the expected return? Well, the expected return is we take the chance of a boom, which is 0.4, and we multiply it times that portfolio return in that state. And then we add the percent chance of a bust, and we multiply it times the portfolio return in the event of a bust. Okay? So then your expected return becomes 0.5 times 6 plus 0.5 times 13, okay, which is going to give you 9.5. Okay? So that's just one of the many ways that you can kind of construct this portfolio. All right? So hopefully you guys can see that. And if I were like constructing these slides, I would just delete this. Like, don't worry about that. Okay, how do I highlight it in black? Well, that did nothing. What happened there? Highlight in black. Okay, wait, I had a cross through. There it is. Just ignore that. This is just here to confuse you because it references you back to these returns, okay? But whatever the case is, you get an expected return of 9.5 from your portfolio. And then how do you calculate the variance? Well, you go back to this formula, okay? You use that 9.5. You see that the average return, okay, of this portfolio in a boom cycle is going to be 12.5. We subtract the average return of 9.5 from it, square it, and then multiply it times this probability that we're in a boom cycle. And then you do the same thing in a bust cycle. So this is the probability of a bust cycle. You're going to multiply it times the square difference between the return in a bust cycle for this portfolio and the average return for the portfolio here. Okay, square it, and then, add the two together, right? So that should give you a 6% squared. When you take the square root of 6, you're going to get a standard deviation of 2.45%. That's pretty good. That's not a whole lot of volatility. Okay, now, common mistake, the variance is not equal to 0.5 times 384. Remember, out here we got 384 when we were just computing variances this way. Okay, so don't just take the variance for asset A, the variance for asset B, add them together, and then, or scale them by the weight that you put on each asset, add them together, and then take the square root. Like, just don't do this. Now, again, you weren't going to do this until the notes showed you, so just ignore that. Okay, this is the right way. All right, everybody kind of understand? All right, so complicated, yes, but not impossible to do. Let's work it out. Okay, so again, the formatting in this slide is hilarious. All right, that's better. Okay, do y'all want to take some time to do it? I'll let you guys do it because I think practice is important. So I'll give you guys 7 minutes until 4:40 to solve this problem. I mean, don't cheat. Like, I know the difference is right here, but try to do it. Try to do it. Okay. And if you have any questions as you're trying to do it, please ask me. Hopefully everybody is getting close. Let's see, I'll give you guys about 1 more minute and 15 seconds. Now on the test, then we do have, I was just reviewing the test, we have several problems like this. So understand that, they probably take 5 or 6 minutes to do. So you want to take some of the other problems that are a little bit easier and solve them really quickly so that you can get these problems right. Okay, so it is 4:40. Let me kind of go over the correct way to do this, although I'm sure you guys don't need it. You've all done it. I'm sure it's right, but let's just make sure to check your answers here. All right, so the portfolio returns we're going to get just by taking the all of the stocks and weighting, right, each stock by how much is invested in each. Okay, so in a boom cycle, you know that 60% of your portfolio is an asset X, and you know that the remainder of your portfolio, 40%, is an asset Z. So take those proportions, they're going to be here, and multiply them by the corresponding returns in a boom cycle. Add them together, you get 13%. You do this, you get the same thing when you do that for the normal cycle. You get 9.6%. You do the same thing for the recessionary cycle, a recessionary state. You get 7%. So then your expected return is just going to be these percentages that you just calculated, okay, multiplied by the chance, the probability that that state occurs. So 13%, that's in a boom. State probability is 25%, so you get 13% times 25. Then there is a 60% chance of a normal economy. So you take 9.6, which is your average return on this portfolio in a normal economy, and then you multiply it times 0.6. Okay, same thing with a recession, you get 10.06%. Now you can calculate the variance. Okay, so now you can come over here and look and again use the same probability weights as you did for expected return, but now subtract the portfolio return, which is 13, minus the average portfolio return across all states. Okay, so this is the portfolio return in the boom state. This is the portfolio return, expected return in all states. Okay, square it, multiply it times the weight. All right, now you get a variance of 3.69 and a standard deviation of 1.92. Okay, so you can also compare to return on X of 10.5% and a standard deviation of 3.12 and a return on Z of 9.4% and a standard deviation of 0.49. Okay, you can also use some covariances. Okay, I don't think I include this on the test, but just in case you're curious, okay, you can go through and calculate the covariance between X and Z, and you can see that it is 0.3. And the way you would calculate this covariance is you would go through, is you would take the weight, right, the probability of this economic state, okay, and then go through and figure out using the return of X, which is 10.5, okay, and the standard deviation of X and the return of Z and the standard deviation of 0.49. So what you would do up here is you take 15, okay, minus 10.5, all right, multiplied by 10 minus 9.4, okay, and so that's in that state. Then 0.6 10 minus 10.5. Again, where did the 10 come from? It came from the slide, right? 10.5 came from here. The 9, and then you got 9 minus 9.4. Okay, and so you can do all of this across the board, and then you would have a covariance of 0.3. All right. So, by the way, you guys are like, where's the 9? Where the 9 is right here. Okay, so you're subtracting the actual return in the normal state minus the return of z, the expected return of z, across all states. And then you get a covariance of 0.3, and then you can calculate the portfolio variance, all right, by taking 0.6 times 3.12. There's your 3.12, by the way, squared, plus the weight 0.4 times 0.49. Yep, nope. There, that's your 0.49 plus 2 times 0.6 times 0.4 times 0.3. And so that'll get you your portfolio variance, and your portfolio standard deviation is again the same as you would expect here of 1.92. Okay, so you can get there using covariances as well. If you go look up the formula for covariance and apply it, you can get there that way too. Okay, so I don't know if you'll have time on the test to do it both ways. Yes, sir. You want to use the first one. Again, this is sort of like the notes are trying to really take you higher. Don't worry about this. You don't have to do it this way. Okay, worry about this. Okay, so don't, after the word compare, you don't need to worry about that for the test. But maybe you just wanted to know, how do I do it using covariances? That's how you do it. But the much easier, more straightforward way is to do it like this. Okay, but if you wanted a sanity check, right, you want to check your calculations. Sometimes it's possible to arrive at the same answer in two different paths, and this is another path you could take if you wanted to. You don't have to. It's a multiple choice. I'm not going to check your work. Okay, realized returns are generally not equal to expected returns. Okay, so that's something you guys know. So just be aware that there are things that are baked into the expectation, and there are things that happen that can't be accounted for in expectation. So these are good estimates for what might happen next year. But if you recall, there were all sorts of very, very smart people at JP Morgan Chase and all these other banks were publishing their forecasts for the S&P 500, and they were doing something similar to this. But the S&P 500 this year has greatly outperformed almost all of those forecasts already, and it's only March. So yeah, you got expectations, but even the professionals get them wrong sometimes. So, and by sometimes I mean all the time. Okay, so part of this is because of news, right? Last week, we talked about a set of news that came from the Federal Reserve, and you saw how quickly the markets reacted to that news. In fact, they seem to be reacting to like almost Powell's every sentence. Maybe not every word, but definitely every sentence. And you can see almost no volatility prior to Jerome Powell's Federal Reserve speech, and then tremendous amount of volatility and upside price action after he spoke. Okay, and so there are things in these announcements that are expected and unexpected. So one of the things that was probably expected from Powell's announcement was that he probably was not going to hike rates. Okay, I mean, inflation was rising, but it wasn't rising so much that it warranted a hike. And frankly, the Federal Reserve sort of winked at everybody and promised they were going to lower rates. So how are they going to backtrack now and hike the rates? And most people expected the Federal Reserve that day not to move the rates up or down. And that's what happened. And so that was kind of an expected component. I think what was surprising was the optimism that the Fed sort of expressed that they had beaten inflation. Okay? There are a lot of reasons to think that that optimism might be misplaced. For example, usually the Fed's target for inflation is 2% or a little bit lower, and the inflation target, as measured by the CPI, the Consumer Price Index, is at about 3.1 or 3.2%. Okay, so it's not down. In fact, if you look at it that way, it's more than 50% above the Federal Reserve's target. If you look at the recent months, inflation has been creeping upward. So, I forgot what it was this reading, 3.2 or 3.3, but the month before that it was 3.1, and the month before that it was 3.0. So inflation's actually rising. That's not good. Year over year, that's the number. So it's 3.3% greater than it was, or the prices are 3.3% greater than they were last year. Month over month, it's also climbing, meaning that the read came in that this month prices was 0.4% higher than last month. Imagine if that were annualized, like that's 4.8%. If you multiply that times 12 months, we can't have that every month. That's a lot of inflation. So the Federal Reserve expressed some optimism that inflation, they're getting close to ending the inflation fight, even though inflation has not been beaten. And so to the market, that was a little bit surprising, but it was a positive surprise because, yeah, the market maybe doesn't want inflation, but what they want even more than inflation is they would prefer to have lower rates from the Federal Reserve, even if inflation occurred. Okay. So because of that, they're like, it's not ideal that we haven't beaten inflation, but if the Federal Reserve is thinking we did, maybe that's actually good for our business, right? So that part in that example we looked at last week is a really clear example of how these announcements can ultimately impact stocks, how some of them are very obvious and some of them are quite unexpected. Okay. But again, we should think about efficient markets. So the idea is that, these unexpected portions of announcements are traded away very quickly. So you saw the reaction to Powell's words and how much trading and volatility there was based on everything that he said. And that's what's happening, right? People traded on the surprise, but very quickly the efficiency of the market meant that all those smart people were able to reach a consensus about what that surprise should mean for the price of the S&P 500 index, for example, and very probably all of the 500 stocks within that index. All right, so let's talk about some of the risks, because some of the risks are systemic, or systematic as they call it. You hear me say the word systemic, I mean systematic. What's the difference? I'm not entirely sure. You'd have to go look up the words in a dictionary. To me, they sound similar, and they are similar. So, so the idea is that there are a lot of risk factors that affect everybody. Again, S&P 500, right? What was the Federal Reserve going to do? That impacted all the stocks in the S&P 500. That's a good example of a systemic risk or systematic risk. Okay, so again, things like GDP readings, inflation, interest rates, so on. By the way, I think GDP comes out this Thursday, in case you're paying attention, for the United States. So people might be trading on that number. It's the final read for the fourth quarter of 2023. But those are systematic, right? So the idea is that every firm is impacted by inflation. Every firm is impacted by the Federal Reserve raising or lowering rates. So that is kind of baked into the cake. You can't diversify away that risk because it affects everybody. On the other hand, there are some risks that are, very focused. Okay, they're industry specific. For example, the price of well, I don't want to say the price of oil because that kind of impacts everybody, but some people more than others. Let's say the abundance of computer chips, right? That's going to impact Tesla and Microsoft and Apple. It's probably not going to impact your local utility company, okay? So clearly, one risk, the Federal Reserve, is systemic, but some risks are specific to general firms. And yes, everything is connected these days, but there's still firms that do vastly different things, right? So a firm that sells farm equipment without any artificial intelligence, just a tractor that you drive around on your farm, right? That they're not going to be impacted by a chip shortage nearly as much as Microsoft is. Okay? There we go. So yeah, that's unsystematic risk, just means it's specific to your firm or perhaps specific to your industry. Okay. So the reason we talk about these risks, and we'll come back to them, is because the risk that is not systematic can be diversified away. You can get rid of it because you can just buy a whole bunch of different firms in different industries so that a chip shortage doesn't impact you so much, because in addition to your Microsoft stock, you also hold the stock that produces farm equipment. So if something happens to Microsoft, right, that stock will still keep your portfolio up and floating. But the systemic risk cannot be diversified away, because no matter what stock you buy, it's going to be impacted by inflation. All right. So let's talk about returns. Well, you got the expected returns and the unexpected returns. And the unexpected returns can have the systematic portion and the unsystematic portion. Okay. So the way you can really express them is the total return is the expected return plus the systematic portion plus the unsystematic portion. Okay. Because again, those portions can be positive or negative. So what you can do is you can diversify your portfolio and get rid of the unsystematic risk. So diversification sort of is a way to de-risk your portfolio sort of for free, right? You get it for free because just by diversifying your assets, you no longer face the unsystematic risk. You still face the systematic risk, but not the unsystematic risk. So the idea of portfolio diversification just means you buy several different assets. You buy stocks in different sectors. It doesn't mean you hold a lot of assets. That's not enough. If you buy Apple, and a bunch of stocks like Apple, like, Apple, Microsoft, NVIDIA, all these, tech stocks that seem to move all together, right? If you buy all of them together, then they're different companies and it's better than just holding one of them, but they're all in one very specific sector. Okay, so if something happens, if there's a worldwide internet crash of some kind, who knows, maybe some kind of internet virus brings the whole system down, all of those stocks are going to suffer together. Okay, so Apple might suffer differently than Microsoft, but similar companies, similar product lines, not very diverse. But if you own 50 stocks, different industries, you got Microsoft and Tesla, like electronics, right? Internet stocks. You've got the oil sector. You've got the shipping sector. You've got all these other sectors, car manufacturers, all these other things. Then a disaster in one sector, it'll bring your portfolio down, but not as much, right? Because now only a 1/20th or 5% of your portfolio is in that sector. So here is what you would need to basically be considered quote unquote diversified. Okay. So basically you can see that on the left in column 1 is the number of stocks in your portfolio. And then in column 2, you have the standard deviation of annual portfolio returns. And in column 3, you have the ratio of portfolio standard deviation to the standard deviation of a single stock. So you can see that it sort of asymptotically approaches 0.39, doesn't it? Right? So you can come up here and you can see that, you're at like 0.44 here, 0.42, 0.42, 0.41, 0.4, and then almost no matter how many additional stocks you add, you're still at 0.39, right? If you're really zoomed in, you're making a difference at some, 5 or 6 decimal points down from zero, but from the initial zero, but it's very hard to tell the difference. And you can also see that the standard deviation basically climbs, right? You go from 50%, which think about that on a bell curve, like that's pretty heavy, to basically the standard deviation, if you recall, of the S&P 500 index, which is 19.2. So buying the S&P 500 index is considered pretty diversified. And so there you are, right? You've now reached basically max diversification once you start approaching 20 or 30 stocks. Okay, see, for 20, you got 21.68. For 30, you got 20.87. After that, if you've properly diversified, right, you're not going to have that much of an advantage buying more and more and more stocks. But a lot of people still buy the S&P 500 because it's so easy, right? There's not, you could go and select 400 of your own stocks, spend a tremendous amount of time on it, or with one click of a button, you can just buy the S&P 500, you get 500 stocks. Let's face it, nobody really knows what 500 different companies are doing, but you're diversified, right? It's very fast and efficient. That's why a lot of people, including many millionaires in America, they're just invested in the S&P 500. And that, by the way, is what Warren Buffett talks about. Warren Buffett is like, yeah, this happens all the time. So, if you're not me, he says, if you're not Warren Buffett, you might want to consider the S&P 500. The idea of diversification is it reduces the variability in your returns. Okay. And basically, it's sort of like don't put all of your eggs in one basket. The idea is that it's very, very hard to know which S&P 500 stock is going to do great and which is going to do horrible. I mean, if you look at the S&P 500 now, Tesla is one of the worst performing stocks this year. Last year, it was one of the best performing stocks. So who could have predicted that, right? It's very hard to tell. Last year, the story was like the Magnificent Seven. Tesla, Amazon, Facebook, Apple, Microsoft. You look at the Magnificent Seven now, they were credited with pulling the market up last year, and about half of them are doing pretty bad this year. So it's very, very hard to predict which stock is going to rise and which stock is going to fall. But the idea is that because people don't like to live in a world of up and down, up and down, up and down, it's better to really spread out all of your bets across these 500 securities, and then you will very gradually go up because one or two securities, or let's say 7 securities, will pull that index up one year, and next year it might be a completely different 7 securities and they'll pull it up that year and so on. Okay, but don't be confused about this. You also diversify your positive returns. So obviously, it's not as good to invest in the S&P 500 as it is to invest in the stock, if you are correct, that is going to make 30 or 40%, right? Because, if the S&P 500 is going to give you an average 10, and the stock you pick is going to give you 30 or 40%, by investing only a part of your portfolio in that stock, you've missed out on the gains you would have gotten had you invested all of your money in that stock. But what you're going to learn very quickly is it's very hard to pick that 1 or 2 stocks, right? It's hard to know. And because you do not know, if you put all your money just in one stock, it's very easy for that stock to plummet and you lose all your savings. That stresses people out. They can't do that. And with just one stock, it could go to zero. Remember stocks like Blockbuster, Enron, Lehman Brothers, those were huge companies and just evaporated, right? So when you pick one stock, that's the danger. S&P 500, if the top 500 firms in the world go to zero, you've got significantly bigger problems in a $0 portfolio. Like we're in World War IV or something like that at that point. So that's why people diversify. But recall that one of the things that it does is you also diversify your positive returns. You don't get as much on the bets that came out positive. So here's just another way to kind of look at these charts. And you can see that you basically can't get below 19.2. And so the idea is that no matter how much you diversify, that risk is systematic, excuse me. It's systematic. You can't diversify it away. All right. On the other hand, this sliver right here, the light blue, that's diversifiable risk. You can get rid of that risk as long as you just spread your portfolio across those sectors. Okay. So what do we need to know about diversifiable risk? You can eliminate it from your portfolio. So if you're a portfolio manager, you've got clients and they don't like risk, hey, you just diversify, right? You get rid of that risk that they hate so much. Okay. So it's basically considered the same as unsystematic risk. And the basic idea is that if we only hold one asset in the same industry, we've got a lot of exposure. If we diversify, we eliminate some of that problem. Okay. But of course, total risk is combining those risks together, right? And if you've got a well-diversified portfolio, the unsystematic risk is small, but the systematic risk is going to be it's going to be the same because you're part of this market system. It's like gravity. You can't get rid of it without leaving Earth, you know? So you're gonna be stuck with the idea of this total risk. But then you've got the systematic risk principle. Now, this is what you get a reward for. You're not going to get a reward for bearing unsystematic risk because the idea is that you, the investor, should know I can get rid of it by myself. So nobody is going to reward you for taking unsystematic risk. But systematic risk, which is inherent in the United States and stock market, and frankly in all stock markets, we have to give you a reward for taking that. Hey, that's your risk premium, guys. So there's not a reward for bearing risk that is unnecessary. So if you're just a risk taker, nobody's going to pay you just to take risks. But the necessary risk, yes, people will pay you for that. Okay. So since unsystematic risk can be diversified away, the risk premium is going to depend on the systematic risk. Oh, skip too many. Okay, got that one? Yes. But how do we measure it? Okay, well, there was a question last class, which was a good question. It was with the beta. Now, I want to amend my answer because I slipped into a common trope where I talked of beta as a correlation. It's not exactly a correlation. A correlation says if, this stock goes up by $1, the next stock goes up by $1 or $2 or $3 or $100, that's still a correlation of 1. The beauty of beta is it's actually better than just the correlation because it doesn't just tell you if this goes up, I also go up. It tells you how much. Remember how I said you've got a beta of 1.29 or 1.2 or 2.4, right? That number shows you the direction and the magnitude, okay? So if you got a beta that's greater than 1, okay, then when the whole market goes up 1%, you on average, not always, okay, but you can be expected to go your beta times the return on the market minus the return on risk-free asset. Okay, I'm going to show you this in a moment, just using the CAPM formula. So basically, if you got a beta that is greater than 1, right, the stock has more systematic risk than the overall market. And it's going to usually be more volatile, okay? If you've got a beta that's less than 1, vice versa, right? So beta measures that systematic risk, okay? And it's going to be very useful to us here in a minute. Here are some betas. This should be what you expect. I think this is in 2017, so you can look up these betas now. But it should be kind of expected, right? So some of these I'm sort of puzzled by, like Twitter. I mean, Twitter doesn't trade anymore on the market, so I don't know what its beta is because Elon Musk bought it and took it private. I was surprised to see that it was less than 1. I thought as a tech stock, it would jump up and down with the markets, You've got Johnson & Johnson, right? I mean, they sell like soap products and things like that. Like they're good because they sell things that people need, but they sell soap. I mean, how much systematic risk can there be in selling soap? I mean, it's soap. You need it to wash your hands. It's kind of a low beta. Coca-Cola, the same thing. I mean, there's nothing really new about Coca-Cola. They alter the recipe a little bit from time to time, from nation to nation, right? But there's nothing like revolutionary happening to where this sugar water, as Steve Jobs used to call it, has now become very different. On the other hand, you get to companies like Tesla and Apple. Yeah, you see higher betas. Like they've got a lot of systematic risk, and they can be pretty volatile. Ford in 2017 wasn't doing so well, so its beta was up also. It doesn't necessarily mean that like your beta being up doesn't mean you're doing poorly necessarily, but Ford was exposed to a lot of systematic risk, more so than the average firm in the S&P 500. I was very surprised to see CBS up here. I mean, what's happening to CBS that's making it so exposed to risk? But something is, clearly. So, yes, go ahead. Unsystematic risk is something that is very specific to one of these companies. So let's look at Apple, for example. All right, let's say for whatever reason, they could no longer get chips for their iPhones. Okay. That would affect Apple, but it wouldn't affect Johnson & Johnson, who makes soap, right? It wouldn't really affect Coca-Cola, right? Because Coca-Cola makes sugar water, right? It might affect Twitter, okay? And it might affect some of these other firms, but it probably wouldn't affect Pfizer very much. And I'm not sure to what extent it would affect Ford or CBS Corporation. So you can see that that's an example of risk that might affect a few of the firms, but not all of the firms. On the other hand, if you have inflation, all of these firms are going to be affected by inflation. Yeah, that's systematic. Inflation is systematic, whereas a chip shortage is unsystematic. That's going to be systematic. I'm pretty sure. I mean, like, it's true that some firms are more impacted from it than others. There's always a little bit of subjectivity there, but it 100%. Like, tell me of a firm that wasn't affected by COVID. You know? Well, COVID-19 specifically. If there's some random virus in Australia, let's say, and it never gets out of Australia, maybe not, right? Maybe it only affects the firms in Australia. And there are many viruses that are not that contagious, right? So that would be an example. But COVID-19, very contagious, right? So that's going to be systematic, okay? Because it's spread all over the globe. So yes, I grant you there's sort of like a gray line. How much does it have to spread? Like, and does it have to infect 30% of all people, or 29? 30 is enough, 29 is not. Don't think about it that way. Just understand that there's sort of a mathematical way to capture the systematic risk, and the unsystematic risk you have to diversify away. Okay. I see puzzled faces. Well, you guys, we're going to have another class on it. Let me conclude here. We'll have another class on it, and I have office hours today and tomorrow and Thursday. So feel free to ask if you have these questions. But there are some examples we just went over in the slides for what systemic risk is. So inflation, GDP, I gave you another one, which is the Federal Reserve rates. But things that affect the company directly, that's unsystematic. Okay, this company only is affected. That's not the system. That's just that company. Okay. All right, you're free.